Welcome, dear students. Today we are going to study about arithmetic progression of standard 10. Now, before going to the exercise, let us learn about what is a sequence and what is an arithmetic progression. Sequence means a set of numbers where the numbers are arranged in a definite order is called a sequence. Now some examples are given here. Now look at this, the set of natural numbers 1, 2, 3, 4, 5. So the difference is 1. 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, etc. So this is an example of a sequence. Similarly, set of even numbers 2, 4, 6, 8, 10. Even set of odd numbers also 1, 3, 5, 7, etc. So these are examples of sequences. Even this, look at this example 1, 2, 4, 7, 11, 16. Now there is a pattern, there is a rule. Now 1 plus 1. Here when we add 1, we are getting 2. Now similarly plus 2 we are getting 4 and plus 3 we are getting 7, plus 4 we are getting 11, plus 5 we are getting 16. So the difference between these two numbers is 1, between these two is 2, here 3, 4, 5 and so on. So this is also an example of a sequence. Now look at this, this is 3, 6, 9, 12, 15, etc. Now the difference is 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12, 12 plus 3, 15 and so on. Now look at this, this is also sequence. So 0, 1, 1, 2, 3, 5, 8, 13, etc. Now what is the order or a pattern here? Now 0 plus 1, 0 plus 1, when you add these two, you are getting the next number. When you add these two, 1 plus 1 is equal to 2 and next is 1 plus 2 equal to 3, 2 plus 3 equal to 5, 3 plus 5 equal to 8, 5 plus 8 equal to 13 and so on. So there is a rule or a pattern. So this is also a sequence. Now next 2, 4, 8, 16, 32, 64, etc. Now what is the pattern here? Now when you multiply this by 2, the first number by 2, you are getting the second number, and second number multiplied by 2, you are getting the third number. Similarly, third number multiplied by 2, you are getting the fourth number. Again when you multiply 16 by 2, you are getting 32 and it's so on, it will go on that way. Next is 1, 4, 9, 16, 25, 36, etc. Now here these are the squares of natural numbers. 1 square, 2 square, 3 square, 4 square, 5 square, 6 square and so on. Okay, so this is also a sequence. Even this, look at this 7, 7, 7, 7, 7, the difference is 0. 7 plus 0, 7, 7 plus 0, 7, so the difference is 0. So this is also a sequence. All 8 examples are sequences. Now let us learn about arithmetic progression. What is arithmetic progression? Now arithmetic progression means in the given sequence, if the difference between two consecutive terms is constant, that is very important. If it is constant, then the sequence is called an arithmetic progression. Now in the given examples, let us see. Now here the difference between these two consecutive number is 1. Here also 1. Here also it is 1, 1, etc. So here everywhere the difference is 1, therefore it is constant, so it is an arithmetic progression. Similarly here 2 plus 2 is 4, 4 plus 2 6, 6 plus 2 8, 8 plus 2 is 10. So the difference is again constant, so it is an arithmetic progression. Look at the third example. Now the difference between the first two numbers is 1. Difference between second and third number is 2. And third and fourth number, the difference is 3. Here it is 4, here it is 5. So the difference is not constant. Therefore it is a sequence, but it is not an AP. It is not an AP, but it is a sequence. Now look at this example. Here the difference between the consecutive numbers is 3 plus 3, 3, 3, 3. So here also this is also an AP. Next, this, look at this. Here the difference between these two is 1, and next these two is what? Or the difference between these two is not 1. Again the difference between these two is 1. So here the difference is not constant, therefore this is also not an AP, but it is a sequence. Look at this. Here the second number is obtained by multiplying the previous number by 2. So similarly the third number is also obtained by multiplying the second number by 2, and so on. So everywhere we are adding, here we are multiplying. So this is also not an AP, but this is called a GP. So this year we are learning about AP only. So we are going to learn AP sums. The GP sums we will study later on. Next example, see, look at this. This is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, etc. So this is also not an AP, but it is a sequence. Next, 7, 7, 7, 7, 7. So the difference is 0. The difference is 0. So this is also an AP. Now next is, what is the difference between AP and GP? Now in a set of numbers, if the next term is obtained by adding a particular number to the previous number, then the sequence is called an AP. Now in GP, in a set of numbers, if the next term is obtained by multiplying the previous number by a particular number, then the sequence is called geometric progression, that is GP. Okay. Now here example 6 is GP. Okay, not AP. It is a GP and sequence. Next. Now all sequences are not AP, but all AP are sequences. Now in a sequence, the ordered terms are represented as T1, T2, T3, T4, etc., Tn, Tn plus 1, etc. Now we'll study about the common difference. Now what is common difference? If the difference between two consecutive terms is constant, then it is called as common difference, and it is denoted by D, small d. So common difference D is equal to second term minus first term. Okay, T2 minus T1, or T3 minus T2, or T4 minus T3. In general, we can write this as Tn plus 1 minus Tn. Now, in an AP, if the first term is denoted by A and common difference is D, then the first term T1 is equal to A, T2 equal to A plus D, and just add the common difference with that. T3 will be A plus D plus D, so A plus 2D. Again T4 will be A plus 2D plus D, that will be 3D, and so on. So AP having the first term A and common difference D, then it is written as A plus D, A plus 2D, A plus 3D, etc. Now this common difference can be positive, negative, or 0. Now in this, all the some examples we will see. In the given examples, first I gave you some examples. Everywhere it is positive. Here the common difference is positive, positive, and here also it is positive, and here it is 0. I will give you one example of negative common difference. Now here see, look at this example. Now in this AP, the terms are represented as T1, T2, T3, T4, T5, etc. Now how to calculate D? D is equal to T2 minus T1, or you can take T3 minus T2. Okay, next term minus the previous term, or T4 minus T3, or T5 minus T4. Okay, so it is T2 minus T1 is 20 minus 10, which is equal to 10. Positive it is. Okay, next example is, now look at this. This is in descending order. This AP is in descending order. 100, 70, 40, 10, minus 20, etc. Now the terms are T1, T2, T3, T4, T5. So D is equal to T2 minus T1. Even though if the next term is smaller than the previous number, we have to go according to the rule. D is equal to T2 second term minus first term, or next term minus the previous term. Okay, and therefore it is 70 minus 100, which is equal to minus 30, or 40 minus 70 is also minus 30, or 10 minus 40 is also minus 30. Okay, so that is negative. When minus 20 minus of 10 is equal to what? Minus 30. Now next example is, look at this, 5, 5, 5, 5, 5, T1, T2, T3, T4, T5. So T2 minus T1 equal to 5 minus 5, which is equal to 0. Even T3 minus T2 is also what? 5 minus 5, which is equal to 0. Therefore common difference D can be positive, negative, or 0. I hope you understood, children, and in next class we will see exercise sums.